So our fourth criteria is x approaches negative 1 from the left side. We want our function g to grow without bound. So again, I'm going to pencil in an up arrow. Our fifth criteria, as x approaches negative 1 from the right-hand side, g is going to grow increasingly large negative, so more and more negative. So let's pencil in g over here. Finally, as x values grow more and more negative, that is, we're going out to negative infinity along the x-axis, we want our function to approach negative 1. So let me pencil that in. And now I'm going to connect these, and I want to point out there are many different ways, an infinite number of ways you could sketch your graph, and mine is just one idea of how to do it. There's one possible version of what this graph could look like. It has a vertical asymptote, a very standard one at x equals 2. There's also a vertical asymptote at x equals negative 1, since the limits from either side of this function as we approach this value, x equals negative 1, are approaching either positive or negative infinity. So by definition, this is still a vertical asymptote. And now there is a horizontal asymptote at y equals 2. And as you can see, this function does cross its horizontal asymptote. It does it a few times, and that's allowed. That's fine. And we have one last horizontal asymptote here at y equals negative 1. So to summarize, here is one possible solution for this problem. That is one possible function that meets all of these criteria. Yours might be different. We've used this to identify the vertical asymptotes and the horizontal asymptotes. A big takeaway is that if x is approaching either positive or negative infinity, and you have some number, you have a horizontal asymptote there, as we can see y equals 2 and y equals negative 1. If x is approaching some finite value from either the left or the right, and you end up with a limit that is either positive or negative infinity, that is, the function is growing in the positive or negative direction without bound, that should tell you that you have a vertical asymptote. I hope this video was helpful.